Now next problem is also an easy problem, provided you know the concepts of the cube roots of unity. We are given that n is an odd integer which is greater than 3, but n is not of the form 3k, that is, it is not a multiple of 3. We need to prove that x cube plus x square plus x is a factor of this expression. So let us simplify this one. This becomes x times x square plus x plus 1, and we know that this quadratic has the roots omega and omega square. So this entire factor becomes x into x minus omega into x minus omega square. And in order to prove that this is a factor of this, we just need to prove that 0, omega and omega square satisfy x plus 1 power n minus x power n minus 1 equals 0. So case 1, x equals 0. Very clearly, on putting x equals 0, this becomes 1 minus 1, which is equal to 0. So this definitely satisfies. Case 2, x equals omega. This becomes omega plus 1 power n minus omega power n minus 1, and we know that omega square plus omega plus 1 equals 0, since omega is a factor of this quadratic. So omega plus 1 is equal to minus omega square, so this becomes minus omega square power n minus omega power n minus 1. Now since n is an odd integer greater than 3, and definitely it is not a multiple of 3, so this becomes minus omega power 2n minus omega power n minus 1, and since n is not a factor of 3, the value of this expression is equal to minus times omega power 2n plus omega power n plus 1, which is equal to 0, since omega is again a root of this quadratic. So we need to prove for omega square just. So our case 3 is x equals omega square. We have proved for x equals 0, x equals omega. Now we just need to prove for x equals omega square. So expression becomes omega square plus 1 power n minus omega power 2n minus 1, and we know that omega square plus 1 is equal to minus omega. So this becomes minus omega power n minus omega power 2n minus 1, which is the same expression as we got earlier. The value of this expression is also equal to 0. Hence we have proved that on putting x equals 0, omega and omega square, the value of the expression x plus 1 power n minus x power n minus 1 gets equal to 0. Hence x equals 0, x equals omega and x equals omega square are the roots of the equation x plus 1 power n minus x power n minus 1 equals 0, which is the desired result to be proved.